In this lesson, we will look at Unit 6, Section 6.5, slope point form of the equation for a linear function. In this lesson, you will learn how to express a linear relation in slope point form. Next, generalize and explain strategies for graphing a linear relation in slope point form, and then graph a linear relation given slope point form. In the previous lesson, we discussed slope-intercept form, which is where y equals mx plus b. M stands for slope, and b is the y-intercept. Slope point form is a little different. In slope point form, both the slope and the coordinates of a point on the line can be identified from the equation. This line has slope and passes through the point x1, y1. And another point on the line is q, x, and y. So we look at the graph that's given here. Slope is just going to represent m, so that stays as m in our equation. And we're looking at two coordinate points. We're looking at point x1, y1, and we're looking at point q, x, and y. So our slope point formula becomes y subtract y1, which equals m, and then in brackets we have x subtract x1. So when we want to look at slope point formula, we will need to substitute in one coordinate point for x1, y1, and determine the slope of the line for m. The equation of a linear function can be written in slope point form when the slope and y-intercept is given. So for an example, write an equation in slope point form for a line with a slope of -4 and where the line will pass through the point -3 and 5. So easily enough, we can take the slope, which is already given. There's nothing to solve for. You will substitute -4 in for your m, and you will do the same for -3 and 5, where -3 is your x1 coordinate and y1 will be 5. So if you go x subtract a -3, that will give us x plus 3. If we have y subtract 5, that will give us y subtract 5 in our equation. So as a result, we will have y subtract 5 equals -4, and in brackets, x plus 3. This type of equation helps us to easily determine a point that lies on the linear function, since we can just easily look at the x and y parts of our equation. The equation of a linear function can also be written in slope point form when given a graph. So write an equation in slope point form for the line that is given. So we start off with our base equation, y subtract y1, which equals m. Then we have x subtract x1. We can find the slope by using 2 points on the line. Form your right triangle to determine the rise and the run. You will have a rise of 1 and a run of 3. The line is decreasing, therefore the rise will be -3. This will produce a slope of -1/3. Next, we can choose any point that is on this line for our x1, y1 point, and the point that was chosen here was point 1, 1. When we substitute that in for x1, y1, we will have y subtract 1 equals -1/3 x subtract 1. Graphing slope point form is very similar to graphing slope-intercept form. Instead of having to find the y-intercept, we are going to plot the point that is given, which in this case we will take the opposite value of the x plus 4 and y subtract 2. which will give us a point of -4 and +2. So you will plot that point first. Always start off with the coordinate point in the slope point form. From there, you're going to use your slope of rise of 1 and a run of 3. You're going to go up 1 unit and over 3. Up 1 unit to the right 3. And you're going to continue that process as long as you want until you're finished drawing your line segment. Now, in summary, the equation of a linear function can be written in slope point form: y subtract y1, which equals mx subtract x1, where m is the slope of the line and x1, y1 is a point on the line. It can be any point on the line if it is not already determined for you on the graph. Slope point form can be written when given slope and a point, where you just automatically substitute both of those in there. 2 points, where you have to find your slope first using your slope formula. Then you can use 1 point for the coordinate point x1, y1. The graph, where the point will already be given to you, where you have to choose, and you find the slope using rise over run, or the slope that is parallel or perpendicular to another line and a point. So you may be given a line that is parallel and asked to write another equation for a line that is parallel to the line given or is perpendicular, and we will look at that later in the review section. Next, when graphing a function in slope point form, start with plotting a point first. So you start off with a point that is in the equation, use the slope in terms of rise over run, and then you'll go ahead using your up or down or left and right method.